Okay, so you know what you're doing. Just listen up a second. So you know what you're doing. You're building, well, not necessarily that circuit on the board, but something very, very similar to it taken from the reference that I've given you at the bottom of the page there. I think almost university, everyone's building that. I would suggest you try and build a double one when it comes to the simulation in multi-sim, but for the on-the-board one, just getting that to work on a single hopper, in other words, a single little motor will be absolutely fine. So, what's the deadline for the assignment? Well done. So, it took me a few minutes to remember it this morning, but so we're 26th of February, and should it be a huge great shock, oh my god, the day before I've got to write an assignment? No, it shouldn't. So you're gathering all the stuff that you've got, your mobile phone's your best friend, photograph what you're doing, get screen grabs of what you're doing, and your life will be a lot easier. The explanations that you need, even if you don't understand it at all, you go to the references and you get a reasonable explanation of how that circuit works. As long as you reference it, everything's fine, nobody's going to say anything, okay? So it's that magic down the bottom, whatever it happens to be. But it's not entirely your work, you're just interpreting it, but here was the inspiration that you got, if you like. So 26th of February, and we're obviously photocopying. And you can see the guidelines on the 721 page about writing a report. And I'm a very nice chap, so what I do is if you put your report in front of me as it progresses, I usually give you some verbal feedback in the labs as well to try and help you along. So that's another motivation for writing it as you go along. Okay, so your photo popper, the one on the board, but I recommend it's the double one. You know what I mean by that. It's got two motors on it. It's essentially duplicating the same circuit twice, basically. Nothing more sophisticated than that. You can also see from the references that they quite often replace those diodes with LEDs. And why do they do that? Well, because what the LED can do is it can work in reverse, and it can work as a photodiode, and it can pick up light. So what that means is you bias one side to fire before the other side. So in other words, when you point your mobile phone flashlight at it, the side that you shine on will be the side that the insect turns towards. That's a nice little addition. And it's almost free just to change the diodes to the LEDs. So consider that LED one. Your barrow boarding, which is great, because I like to see things physically made, and it also helps you to sanity test yourself that, well, that circuit is worth putting on a PCB, because it works, and you can demonstrate it works. If you try to simulate this, and this is important, I didn't tell you this last week, but if you try to simulate in multi-sim, it's a monostable. In other words, a monostable, I was speaking about seesaws, didn't I? So you've got your little kid brother on the other end and you sit on one end. Obviously they're going to go up in the end, you're going to go down, and it's going to stay like that, right? Whereas if you've got two little kid brothers either side, they're going to bounce up and down from the seesaw. Monostable and multi-vibrator. That circuit that you're building in the simulator will not multi-vibrate. It will just charge, discharge, and then it will remain discharged forever. That doesn't matter, because all you're interested in is that little time frame where it charged and discharged through the transistor into the little motor there at the end. So anyone with their hands in the air, it doesn't oscillate, it won't. But the one that you build on the real circuit board will, strangely enough, because multi-sim can't cope with the fact that you're collapsing the supply. Remember what you're doing. You've all seen these waveforms before, haven't you? So you've got your voltage increasing here, the time here, And what happens is we get this charge, and I've said that this is about 5 tau, which is, that's the times resistor, that's the times or the internal resistance of the solar panel, but there's a time constant. So you're charging. Now what your circuit's going to do is it's not going to go to the fully charged point, it's going to reach a threshold, which is what that circuit itself does, and it's going to discharge. And then it's going to try and charge up again. But not in the simulator, only in the real world. Okay, but look what we're doing. This is not only the voltage, which is on the 555 timer, but it's also the supply voltage. Now this is unheard of. In all electronics that you have, you've got a little portable radio. The one thing that you would never do is adjust the power supply itself. It's a 9-volt battery, it's meant to be 9 volts. We're playing with the devil here because what we're saying is that the power supply itself we're going to allow to collapse. And that's why you get funny things happening when you try to simulate it. In the real world, if you get your circuit built, we'll rig it up to the oscilloscope, you'll see that charge, discharge. And that, at the point of discharge, which doesn't last very long, half a second to a second, something like that, that's at the point where the little motor will turn and your little robot will go and scuffle a little bit across the floor. Okay? And your metal detector, if you get bored, get a headache, whatever, go in the soldering room and try and get that metal detector put together, yeah? Because I haven't seen one working yet, and last year I think we had 3 or 4 working by this stage, so, but that's just a bit of fun, yeah? But if you put that in your report, would I be influenced to give you another mark? Probably I would. Why not? Because you're demonstrating your hand skills, aren't you? Okay, any questions? Okay, so in about an hour's time, I've got a guy, well, he works for us, but he's got his own electronic design company and does stuff for the NHS and business and all the rest of this kind of stuff to do with monitoring, and he's an expert at PCB design, so he's going to come along and he's going to give you a talk about surface mount components, multi-layer boards, and basically the process of sending those boards away and the manufacturing process and the costs and all that kind of stuff, okay? So guest speaker in about an hour, probably for a 30-minute talk, something like that. Is that okay? Okay, on with your work.